This example is very much like your homework. It takes working from the butt again. So these two are in series. I know that they're in series because if I take this one out, that one won't be on. If I take this one out, that one won't be on. 7, though, doesn't depend on them. So 7 is parallel with these two. So let me figure out first. I have my cluster of 7 plus 7, which is 14. So I unite these and replace them with 14 ohms. And then I have 1 over 7 plus 1 over 14. This is going to be 3 over 14, or then our equivalent of this whole butt, which is these two in series parallel to this one. So 14 over 3, 4.67 ohms. And 4.67 ohms is in turn connected to 1.5 and 7 in series, 4.67, and that gets us about 13.2 ohms. Then 13.2 ohms is the total, and that's my total voltage. So 12 divided by 13.2 gets me 0.91 amps. Again, now let's see how many of these resistors will get that 0.91 amp. How many resistors will get the total current? This one gets that current all to itself, so 0.91. Then part of it goes here, and part of it goes in here. In what ratio? These two are double in resistance of that one. So I know again, 1/3 of the current will go here, is 0.303, if you will, or you can just do 0.3 amps will go here, and then double of that, 0.61, is going to go through 7 by itself. Then my two currents fuse, that's the same. So this also takes my 0.3 amps. That voltage then fuses together with the 0.61 back into 0.91 through 1.5. Let's look at the drops, voltage drops on each one. 0.91 times 7 takes 6.37 volts on this one. 1.5 times 0.91. This takes 1.36 volts. So then I will take that out of 12. So 12 minus my voltage on the ones that are in series with the rest. That gets me 4.27. So that's the voltage by the cluster of 7 and 14. So then if I take my 4.27 and divide by 7, that's how I get my 0.61 amps. All right. So then that voltage of 4.27 is split between 2135 here and 2135 volts here. How do I know that? If I take my 0.3 and multiply by my 7, that's 2.1. It's just more significant figure, right? That's how you solve that one.